Good day everyone, welcome to our class. So for today we're going to discuss the solution of our seatwork. So for problem number 1, we have a simply supported beam with a point load 55 kilonewton and 135 kilonewton. So the first step again in solving or drawing the shear and moment diagram is to compute for the reactions. So taking summation moment at A, clockwise as positive, so we have 0 is equal to 55 multiplied by its moment arm na 3 plus 135 multiplied by its moment arm na 6 minus the reaction at point D multiplied by its moment arm na 9. So ito class ay letter D, R sub D. So R sub D is equal to 108.333 kilonewton. So next, taking summation moment at D class to ha. So we have 0 is equal to 135 multiplied by 3 plus 55 multiplied by 6 minus R sub A multiplied by 9. So R sub A here, the reaction at A is equal to 81.667 kilonewton. So meron na tayong mga reaction. Pwede na tayong mag-draw ng ating shear and moment diagram. So let's start with the shear. So ilan ba yung reaction natin at point A? So ilan na magiging shear natin at A? So drawing lang natin yan dito. So pataas siya since pataas yung reaction natin. That is 81.667. Now from A, going to B, may load ba tayo? Wala. So we're just gonna draw a horizontal line here. And at point B, may pumasok tayo na load. So from 81.667 minus 55, kasi pababa kaya minus. So that is 26.667 kilonewton. Now from B to C, may load ba? Wala. So we're just gonna draw a horizontal line here. And from point C, meron tayo ulit na point load na 135 kilonewton. So from 26.667 kilonewton minus 135 minus, kasi pababa. So that will give us negative 108.33 kilonewton. Now, from point C to D, meron ba tayong load? Wala. So, we're just gonna draw a horizontal line here. Now, at point D, meron tayong pumasok na load. Reaction siya pataas. That is equal to 108.33 kilonewton. So, we have the shear here at point D, negative 108.33 kilonewton plus the reaction 108.33 kilonewton. So, nag-0 tayo sa shear. So, next, dito na tayo class sa moment. So, in computing a moment, again, ang basis natin is itong ating shear diagram. And then, area lang na to. Okay? So, for the first area, A to B, so we have 81.667 multiplied by its base, 3. So, that will give us 245 kilonewton meter. And then, for B to C, so we have 26.667 multiplied by 3. Pero, dito tayo syempre manggagaling, 245 plus this area. So, that will give us 325 kilonewton meter. So, next, for moment C to D, so we have negative 108.33 multiplied by its base, 3 meters. So, again, ang paggagalingan natin is itong 325 minus yung area na to. Minus class yan kasi nandito sa negative part sa ibaba. So, that will give us 0. So, nag-close yung ating moment. So, for this particular beam, ito yung kanyang shear and moment diagram. And, kung i-observe natin to, the maximum shear is maximum positive shear is 81.667 and the maximum negative shear is negative 108.33. Now, for our moment, so the maximum moment is 325 meters. And then, kung ilolocate natin siya, pwede nating sabihin na the maximum moment is 6 meters from point A or the maximum moment is 3 meters from point D. Ngayon, class, kung i-observe ninyo, the maximum moment always happen kung saan meron tayong 0 na shear. So, as we go along, mapapansin nyo that the maximum moment always happen when we have the zero shear. Okay? So, next, we have problem number 2. So, for problem number 2, meron tayong cantilever beam with point load na 70 kilonewton at point B and moment at point C which is 200 kilonewton meter. So, to start, kailangan muna natin ulit mag-compute ng reaction. So, ito naman, basic na siguro sa inyo to. Dahil mechanics pa lang, tin-take up nyo naman ay pag-compute na reaction, right? So, here, taking summation of forces vertical is equal to 0 going up as positive. So, we have 0 is equal to A sub y minus 70. So, A sub y is equal to 70 kilonewton. So, wala man tayong ibang pumasok na point load or vertical forces. So, siya din lang yun. Equal lang sila. 70 kilonewton. So, next naman is taking summation moment at A is equal to 0 counterclockwise as positive. So, we have 0 is equal to m sub A plus 70 multiplied by its moment arm na 6 minus itong ating moment at point C na 200. So, MA is equal to 620 kilonewton meter. So, meron na tayong mga reaction. Pwede na tayong mag-drawing ng ating shear and moment diagram. So, for our shear, ano ba ipapasok? So, ito lang 70 kilonewton ulit, right? So, from here, we have ilan? 70. Itong reaction natin dito. And then, from A to B, meron ba tayong load? Wala. So, from point B, may pumasok na 70. So, 70 minus 70, 0. So, from B to C, meron pa ba tayong load? Wala na. So, dito class, always remember that yung moment natin, itong moment natin na to at ito, ay papasok lang dito sa moment diagram natin. Hindi siya makaka-apekto dito sa ating shear. Okay? So, sa shear, mga reaction and point loads, concentrated loads, yun yung mga pumapasok. Pero kapag may mga given na moment, di yun kasali. Sa moment diagram lang siya. Okay? So, meron na tayong na-draw na shear diagram. We can move on to our moment diagram. So, for our moment diagram, so, dito tayo mag-umpisa. We have 620 here, counterclockwise siya. So, ang mangyayari, pag pinush niya yung beam natin dito, so imagine, ito yung load natin, yung moment natin. Pagka pinush niya to, so ang mangyayari ay magiging sad face yan, right? Pinush niya gayon. Kaya dapat ito ay pababa. So, that is negative 620. So, from here, pwede na tayo mag-compute ng area na to. So, we have 70 multiplied by 6. So, we have negative 620 plus 70 times 6 meters. So, plus siya dito kasi nasa taas siya, diba? Positive yun nasa taas, negative yun nasa ibaba. So, that will give us negative 200 kilonewton meter. So, mula dito sa point B to C, meron pa ba tayong shear? Wala na. So, horizontal lang yan, class. So, mula dito naman, meron tayong moment na pumasok, diba? So, yung moment natin, class, ano siya? Clockwise. So, negative 200 plus 200. So, that will give us 0. Okay? Problem number 3. So, we have an overhanging beam na ang length ay 12 meters. So, meron tayong point load na 265 kilonewton at point B. Meron tayong moment at point C which is 245 kilonewton meter. We also have a uniformly distributed load with the length of 6 meters. So, that is, yung uniformly distributed load natin ay 30 kilonewton per meter. So, to start, we have to compute first for the reaction. So, taking summation moment at A is equal to 0 clockwise as positive. So, we have 0 is equal to 265 multiplied by its moment arm na 3 minus 245 minus since ang assumption natin ng positive is clockwise. So, this one is counterclockwise. So, minus 245. Plus, yung ating uniformly distributed load, 30, multiplied by its length, 6 meters, multiplied by its moment arm na 9. So, dito galing yung 9, 3 plus 3 plus 3. Since ang concentrated load natin dito, class, ay dito pupunta. Okay, sa gitna ng ating 6 meter na uniformly distributed load. Okay, so minus R sub D, reaction na sa D, multiplied by its moment arm na 9. Then, from here, we could solve R sub T, which is equal to 241.11 kilonewton. So, next, taking summation moment at D is equal to 0 counterclockwise as positive. So, we have 0 is equal to 265 multiplied by its moment arm na 6 plus 245 plus 30 multiplied by its length na 6. And then, kung saan tayo nag-compute na reaction, doon nakapwesto concentrated load natin. So, ang mangyayari, so, 0, walang moment arm. Minus R sub A multiplied by 9. So, from here, we could solve R sub A. So, that is 203.88899 kilonewton. Okay? So, meron na tayong mga reaction at point A at point D. So, pwede na tayo mag-start, mag-draw ng ating shear and moment diagram. So, umpisahan natin sa shear. So, at point A, meron tayong reaction na 203.89. So, pataas siya. So, dito siya sa positive. Pataas, 203.89. Ngayon, from A to B, may load ba? Wala. So, mag-draw lang tayong horizontal line. From point B naman, meron tayong pumasok na 265 kilonewton. So, from 203.89 minus 265 kilonewton, that will give us negative 60. Okay, so for our shear, at point A, ano ba ipapasok dito? So, we have the reaction at point A, which is 203.89. So, 203.89, pataas siya since pataas tong reaction natin, positive. So, from A to B, meron ba tayong mga forces dyan? Loads? Wala naman. So, horizontal line lang. And then, at point B, may pumasok tayo na point load na 265. So, from 203.89, liles lang natin yung 265. So, that will give us negative 61.11 kilonewton. Now, from point B to C, may pumasok ba na load? Wala. So, magdodraw lang tayo ng horizontal line. Now, at point C, ilalagay na ba natin itong 245 kilonewton meter? Hindi. So, ano lang ipapasok dyan from C to D? So, ito lang. So, itong 30 kilonewton meter natin multiplied by its length na 3 meters. Ngayon, class, since uniformly distributed to, so pag nag-draw tayo ng shear diagram, plus 1 siya ng slope, so inclined na siya. So, we have negative 151.11 kilonewton. Now, at point D, may pumasok ba na load? Of course, meron tayong reaction at point D, which is 241.11. So, we have negative 151.11 plus 241.11. So, that is 90 kilonewton. Now, from 90 kilonewton, D to E, may pumasok pa tayo na load. So, itong uniformly distributed load natin na 30 kilonewton meter na ang length ay 3 meters. So, we have 30 multiplied by 3, so that is 90. So, 90 minus 30 multiplied by 3, so that will be 0. So, nag-0 na yung ating shear. So, next naman is mag-draw na tayo ng ating moment using the area of our shear. So, for our moment, let's start with this area. So, we have 203.89 multiplied by 3. So, that will give us 611.67. So, dito class, mapapansin nyo, pataas yan. Bakit? Kasi nasa taas itong ating shear, right? Dahil positive siya. Ngayon, pa-incline na siya since plus 1 na tayo ulit ng slope. So, from uniformly distributed, magiging uniformly varying load siya. Okay? So, from 611.67, ima-minus natin yung area from B to C. So, ang area natin from B to C is negative 61.11. So, 611.67 minus 61.11 multiplied by 3. So, we have 428.34 kilonewton meter. Ngayon, sa point C, meron tayo dito class na counterclockwise na load. So, ang ano gagawin natin? So, ima-minus natin yan class dun sa ating nakuha na 428.34 kanina. So, that will give us 183.34 kilonewton meter. So, travel na tayo ulit from C to D. So, from C to D, meron tayo dito class na, ano to, trapezoid. So, kailangan lang natin makuha yung area nung trapezoid na to. So, we have 183.34 minus 1/2 ng height 1 natin. So, ito, 61.11 plus itong height na to, 151.11 multiplied by its base. So, ilay base na to. That is 3 meters. So, that will give us negative 135 kilonewton meter. So, next, dito na tayo sa triangular load na to. So, we have negative 135 minus, this is a triangle lang naman. So, 1/2 base times height. 1/2, ang base natin ay 3 multiplied by its height na 90. So, that is also 135. So, ito class plus ito ha. Sorry Ito dapat ay plus. Negative 135 plus 1/2 90 multiplied by 3. Plus siya kasi nasa taas. Okay? So, yun class. Ang pag-drawing natin ng moment diagram. Ngayon, dinagdag ko lang to. Kasi iba baka nalilito pa dito ha. Ito class ating shear ay, ano to? Increasing, decreasing. So, decreasing. So, kapag decreasing yung ating shear, so ang pag-draw ng ating moment ay concave downward. So, kaya siya pa ganyan. So, next naman ito. Ito bang shear natin from 90 to 0 increasing or decreasing? So, siya ay decreasing. So, pag nag-draw tayo ng moment, that is concave downward pa rin. Okay? Pag ganyan. So, next na tayo. So, here, we have a overhanging beam na merong uniformly varying load na 27 kilonewton per meter. So, from A to B, ang length niya ay 3 meters and from B to C, that is 6 meters. So, pag nag-start tayo dito, class, ano ang gagawin natin? So, compute for the reaction. So, taking summation moment at saan to? Okay, so taking summation moment at point C is equal to 0, counterclockwise as positive. So we have 0 is equal to 1/2 9 multiplied by 27 multiplied by its moment arm na 3. Okay, so saan galing yung 3 na to na moment arm niya? So dito siya mapupunta, 'di ba? 1/3 ng ating 9. So, that is 3. Yun yung moment arm niya. Minus R sub B multiplied by its moment arm na 6. So, sana nagets nito. Ulitin ko lang ha. So, area ng triangle natin, 1/2 multiplied by its base, 9 meters, multiplied by its height, 27 meters. 27 kilonewton per meter. So, ang moment arm niya, class, so, di ba pagka triangle, 1/3 mula sa pinakamataas, and then 2/3 mula sa pinakamababa. So, since C tayo manggagaling, so 1/3 ng total length niya na 9, so that is 3 meters. Okay? So, R sub B is equal to 60.75 kilonewton. So, next naman, class, para makapag-compute tayo na reaction at point C. So, C ito class sorry. So, at point C, so, taking summation moment at B is equal to 0, clockwise as positive. So, makikita nyo class dito sa diagram natin, dinivide ko siya, lalo na itong B to C into 2 shapes. So, we have a triangular load, uniformly varying, and uniformly distributed load. So, itong blue. Okay, so we have 0 is equal to 1/2 6 multiplied by 27 minus 9. Ngayon class, ang tanong kasi dito, ilan ito, 'di ba? Itong part na to. Ito, alam natin to na 27. Pero dito, ano yung magiging height nung green na to? Or yung height ng blue na to, 'di ba? So, ang gagawin lang natin is mag-take tayo ng ratio and proportion. So, we have 27 is to 9, y is to 3. So, from here, we could solve y is equal to 9. 9 kilonewton per meter. So, punta na tayo dito sa moment. Okay? So, ano yung una natin kukuhanin? Itong kulay red. So, ano ba yung area niyan? So, 1/2. Ilan yung base niya? 6. Ilan yung height niya? 27 minus 9 na. Okay? Multiplied by its moment arm na ilan? So, remember, dito tayo nagmo-moment. So, 2/3 ng 6. Okay? So, next naman is itong sa kulay blue. Itong rectangular load natin na to. So, we have 9 multiplied by 6 meters. So, base times height. Multiplied by its moment arm na 3 meters. So, ang centroid pagka rectangle, kalahati niya. So, ano kalahati ng 6? So, that is 3 meters. Minus itong ating triangular load dito. So, that is 1/2 multiplied by its base, 3 meters. Height na 9 meters. And then, mapapansin nyo, ang moment arm natin dito class is 1/3 ng 3 meters. 1/3 kasi dito tayo kukuha, diba? So, ito yung malapit dito. Ito yung kuhanin natin. Kung saan tayo nag-moment. So, minus r sub c multiplied by its moment arm na 6. So, from here, r sub d is equal to, r sub c, is equal to 60.75 kilonewton. So, meron na tayo class reaction. Doon na tayo sa pag-draw ng shear and moment diagram. So, let's start with shear. So, at point A, meron ba tayong shear? Wala. So, 0 tayo mag-umpisa. And then sa B, at point B, pumasok na tayo na uniformly distributed load. Alam naman natin na ang height na to ay 9. So, we have 1/2 base times height, 3 multiplied by its height na 9 meters, plus 60.75 na reaction. So, that will give us 47.25 kilonewton. So, next naman, we have here, so, dito pa rin tayo manggagaling ha, 47.25. Ano to? Plus. So, dito tayo class manggagaling sa 47.25. So, minus, since pababa itong B to C natin na load. Trapezoidal load siya. So, again, dinivide lang natin to into 2. Isang rectangle at isang triangular. So, doon muna tayo sa triangular. So, we have 1/2 multiplied by its base na 6 meters multiplied by its height, 27 minus 9. And then, minus itong ating rectangular load, 9 multiplied by 6. So, that will give us negative 60.75 kilonewton. Then, pagdating natin sa C, ano yung shear natin dyan? So, dito pa din tayo manggagaling sa negative 60.75 plus yung ating reaction na 60.75. So, ang ating shear at C is magsi-0. Okay? So, ngayong class, sa pag-draw ng ating shear diagram, so, dito, ang load diagram natin ay increasing A to B. So, kapag ka-increasing siya, concave downward ang ating shear diagram. So, again, from B to C, ano yung ating load? So, increasing siya. So, from 9 kilonewton meter to 27 kilonewton meter, increasing. So, again, pag nag-draw tayo, that is concave downward. So, ito siya. Concave downward. So, next, doon na tayo sa ating moment diagram. So, sa moment diagram, madali lang i-compute yung from A to B since we have here a spandrel. So, pasok siya sa pagiging spandrel since yung dulo ng ating parabolic curve is nasa vertex. Okay, so we can use x squared over y is equal to b squared over h. Kaso, dito sa squared properties ng parabola, na-derive naman na natin or ipinakita ko naman na sa inyo yung shortcut dati na para ma-solve natin yung area kapag ka-spandrel. So, that is simply 1/3 base times height. Okay? So, we will use this from A to B. 1/3, ang base niya, 3 meters. Height niya, 13.5. Negative 13.5. So, that will give us negative 13.5 kilonewton meter. So, next naman is from B to C. So, from B to C, ito ipapasok, tsaka ito. So, ang problema natin dyan, class, kailangan natin i-divide into 2. So, wala pa din tayong makukuha na x, right? For this one, and add this one. Wala tayo dyan na length. So, hindi natin kaagad masosolve. And also, we cannot use here the squared properties of parabola since, pansinin nyo, so this is another parabolic curve, right? This one. Portis ditong mula sa B to C. So, panibagong parabolic curve yan. Ngayon, pag tiningnan natin yung dulo ng parabolic curve natin, at point B ba, nasa vertex ba tayo ng isang triangle? So, wala. Since, ang nabuo natin dito na natira from B to C is trapezoidal. So, hindi applicable, class, yung x squared over y is equal to b squared over h. So, hindi natin magagamit yung formula na ibinigay ko sa inyo. Okay? So, paano gagawin natin dyan? So, dito, class, kapag medyo complex na yung given natin, the best way to solve this one is to use method of section. So, para ma-solve natin ito, class, from B to D. So, naglagay na tayo dito ng D since dito, 0 yung ating shear eh. Okay. So, dito tayo mag-compute. So, i-consider natin itong side na to, itong kulay blue na to na triangle. Ito siya, pag nilipat ko. And we assume this is x. So, we have A to B, 3 meters. Since A to D is x, so B to D is x minus 3. So, meron tayo reaction at point B. So, that is 60.75 kilonewton. Ngayon, class, ilan to? Wala pa tayong nasosolve na to, diba? Itong y. So, by ratio and proportion, we have 27 is to 9 and then is equal to y over x. So, simplify lang natin to, class. We have y is equal to 3x. So, 27 divided by 9, that is 3. So, y is equal to 3x. Okay? So, kompleto na tayo. Meron na tayong height dito. Y is equal to 3x. Pwede na tayong mag-start sa pag-compute ng ating shear. So, we have V is equal to 60.75 minus 1/2 yung base niya na x multiplied by its height na 3x. So, we have the first equation for shear. We have V is equal to 60.75 minus 1.5x squared. So, ngayon, class, bago tayo pumunta sa moment, eto, tandaan nyo lang to. Ito yung gusto ko i-remind lang din sa inyo. So, sinabi ko naman na to kanina, that the maximum moment always occur where shear is equal to 0. So, using this one, we have V is equal to 0. And gamitin natin itong na-derive natin na equation for shear. So, we have 0 is equal to 60.75 minus 1.5 x squared. So, masasagot na natin kaagad yung x. So, we have here, x is equal to 6.3639. Okay? So, may x na tayo dyan. So, next naman, dito na tayo sa moment. So, taking moment clockwise as positive, considering this left side nga. So, we have 60.75 multiplied by x minus 3 minus 1/2 x multiplied by 3x multiplied by x over 3. Moment arm niya na x over 3. Okay, so simplifying this one, we have our moment 60 minus 75 multiplied by x minus 3 minus 1/2 x cube. Now, substituting the value of x here, so we have 60.75 multiplied by 6.3639 minus 3 minus 1/2 multiplied by 6.3639 cube. So, we have our moment at point D, 75.45. So, dito, class, Pag medyo nahihirapan na kayo, wala namang problema kung babalik tayo sa method of section. So, next naman, dito na tayo, class. So, we have here, again, using this equation na na-derive natin kanina, and then substituting our x here. So, yung buo na i-consider natin, 9 meters. So, we have m is equal to 60.75, 9 minus 3, minus 1 half, 9 cube. So, magsisiro na yung moment natin. Okay, so for this particular beam, ito yung shear and moment diagram niya. So, mapapansin nyo, yung maximum moment natin nag-a-occur kung saan nag-zero yung ating shear. So, ito lang mga ilang reminders. So, always write the numerical value of shear and moment in the diagram. So, kadalasan sa inyo, nag-check ako ng seatwork, nag-drawing lang, walang mga value. So, dapat palagi kayo naglalagay ng ganyan, class. So, next, you can also put the number of slope. So, halimbawa, ito naka-curve to. Ilan ba yung slope niyan? Ito, ilan ba yung slope niyan? So, next naman, so the maximum moment always happen where the shear is 0. So, dito, class, dalawang beses nag-0 yung shear natin at point B and at point D. So, saan siya pinakamataas? So, dito sa point B. So, in locating the maximum moment, you can use ratio and proportion. But for this particular problem, so the maximum moment is saan? 3 meters from point A, or pwede nyo sabihin 9 meters from, 6 meters from point D. Okay. Kapag ka naman tinanong kayo, what is the maximum negative moment? So, negative 135 yung isasagot ninyo. Okay, so that's it, class, for our discussion.